Welcome to Awesome Code. Please subscribe to my YouTube channel. We are going to talk about fundamental linear algebra using Python first. What is a linear algebra? Linear algebra is the branch of mathematics that deals with vector spaces and matrices. It is the mathematics of data dealing with its creation, representation, transformation, and consumption using various concepts of vector and matrices. We are going to learn about matrix algebra using Python. So, what is a matrix? In mathematics, a matrix is a rectangular array of numbers, symbols, or expressions arranged in rows and columns. Matrices are essentially two-dimensional arrays. Let, let's see an example of a 3 by 3 matrix. And here I'm going to just represent our matrix A. Uh, it will have 3 rows and 3 columns. One, two, three. This is the first row with 3 columns. And this will be a second row. And now we will have our third row. This is our first row. And this is our second row. And this is our third row. This is our first column, 1, 4, 7. And this one is our second column, 2, 5, 8. And the last one is the third column, 3, 6, and 9. Now I will have another matrix B. B with 2 rows and 3 columns. So our first row will be 4, 5, 6. And our second row will be 7, 8, 9. Our first row, our second row. So this is matrix 2 by 3, 2 rows and 3 columns. First column is 4 and 7. This is the first column. And then our second column is 5 and an 8. And our third column is 6 and 9. You can count the number of rows in a matrix by counting the horizontal lines of numbers from up to down. Like this is the first row, this is the second row. And you can count the number of columns in a matrix by counting the vertical lines of number from left to right. First column, second column, vertical line, and the third column. We are going to use Numpy for our matrix algebra. What is Numpy? Numpy is a numerical computing library for Python that provides support for multidimensional arrays and matrices, along with associative mathematical functions. Numpy array can be represented as matrices. Let's see, first I'm going to import Numpy as np. Import numpy as np. And now I'm going to create a matrix A using numpy. So I will use np dot matrix. Here is our first matrix, and the same way I'm going to create a matrix B using numpy. So over here I will use np dot matrix. And now we can print matrix. Print matrix A. We are going to print our matrix and a new line. Then I'm going to print our matrix B. Print our matrix B and the new line. Save it. And after we run our Python program, we can see our matrix A and also the matrix B. Now we will see example of addition and subtraction of matrices. As long as the dimensions of the matrix are same, the corresponding element of matrices can be added or subtracted. I will remove one extra row from our matrix A so the both matrix dimension matches. Now we will have both array with 2 rows and 3 columns. 2 rows, 3 columns. And we can perform addition and subtraction. I will remove this code. And first we are going to perform addition of matrices and save the result. So right here, matrix sum is set to matrix A plus matrix B. And now we can perform subtraction of matrices. Matrix, and this will be our difference. A minus B, and we can print the sum and the difference. Print A plus B equals it should be inside those double quotes right here. Print matrix sum, and I will just copy those lines and modify for matrix difference output, and some separator first. So print and then paste those lines after this and change the addition sign to subtraction and change this to matrix diff and run our program. And here are our addition of matrix and the subtraction of matrices. I will clear the terminal. Now we are going to learn about matrix multiplication. Matrix multiplication is a binary operation that produces a matrix from two matrices. For matrix multiplication to be possible, the number of columns in the matrix must be equal to the number of rows in the second matrix. The resultant matrix has number of rows equal to the first matrix and number of columns equals to the second matrix. The first element of the first row of the resultant matrix is the dot product of the first row of the first matrix and the first column of the second matrix. Similarly, the second element of the second row of the resultant matrix is the dot product of the second row of the first matrix and the second column of the second matrix. Other elements are calculated in the same manner. Let's define our two matrices, uh, M and N. M will be a 2 by 3 matrix. That means 2 rows, 3 columns. So I will remove those previous matrices and just delete all the code. And then our first matrix M with 2 rows and 3 columns. 2, 3, 4. First row and the second row. 1, 4, 6. And then we are going to have our matrix N of type 3 by 2 matrix, 3 rows and 2 columns. So over here, our first row for this column, and our second row, in our third row. This matrix contains 3 rows. This is our first row, this is second, this is third, and we have 3 rows and 2 columns. This is our first column, 2, 3, and 1. And our second column, 4, 6, and 5. Here, let's see, square brackets. And I think I need one extra, one more. Yeah. Now we can multiply these matrices. So multiplication goes like this. Over here, the result will be. So the elements of the first matrix row will multiply with the column of the second matrix. So this will be 2. First we are going to pick 2 and we are going to multiply with the first element of the column of second matrix. So that will be 4. Then we are going to add, then we are going to multiply 3 with the second value of the first column. This will be 3, and then we are going to add and multiply 4 with the first column's last value, 1. And in the first row, we are going to select again the first row of first matrix and multiply with the second column of the second matrix. So this will be the first row again, 2 multiply with the second column's first value, 4, then add, then multiply 3 with the second value of second column of matrix n, then we are going to plus, and then we are going to multiply 4 with the second column's third value, 5. This will be our uh, first row for the resulting matrix. And now I will go for the second row of the resulting matrix. So now we are going to select the second row of our first matrix and multiply with the columns of the second matrix. So now we are going to select the second row from first matrix. The first element will multiply with the first column's element of matrix 2, and we are going to plus, and then the second value of the row, that is 4 from first matrix, and multiply with the second value of the first column, and 3. Then we are going to multiply 6 with the third value of first column of second matrix, and then our second column starts by multiplying the first element of the second row, 1, with the second column's first value, 4. Then we are going to add and then multiply 4 with the second value of the second column, and then we are going to multiply the last value of second row with the last value of the second column of matrix n. This will be 5. So our result will be, I'm just doing this manual calculation, then we are going to use the Python code to get the result. Over here, the result will be something like this: uh, 21, 46, and 20, and 58. Okay, we are going to confirm it by using the Python code. I will remove this data and now create a matrix by using np first, and then we are going to multiply those matrices. So we can use the same way uh, we did before. Np dot matrix. This is our first matrix, and this is our second matrix. Np dot matrix, and to here, and there are several methods several ways to perform matrix multiplication using Numpy. First, I'm going to use a matmul function of np, and we are going to get the result. So we get the product mn by calling np dot matmul and pass in our m and n matrix, and we can print the result. And we can do like this. The product of mn is equal to print mn, the product of these two matrices. Let's run our code. So here is the product of our matrix. So my first calculation was wrong. So that this product is 17 and 46, 20, and 58. These are the values. Now we are going to use another method. We can also perform multiplication like this. M is set to M, and we are going to just use asterisk sign for multiplication. This would be M multiply with N, and we are just going to uppercase and I'm going to print the value again. I will just remove from there. So we just want to print the current value, and run our program, and again we get the same result. We can also use np's dot method and pass in these two metrics. So I'm going to try that one too. Here I'm going to do mn equal to np dot method, and we are going to pass in m and n, and we're going to print the value again over here and run our code, and we get the same result again, the product of those two metrics. Also, we need to note this: the resulting matrix product mn is a 2 by 2 matrix, as m has 2 rows, and over here our m has 2 rows, 1 and 2, and n matrix has 2 columns. This is the first column, and this is the second column. To keep on learning, please subscribe to my channel, Awesome Code. Keep supporting me, and thank you for watching.